And okay, so we're going to start with, it's going to go from easy to pretty interesting, all right? I won't say hard, I'll say interesting. And so we're going to start with this guy here, Fibonacci, Leonardo of Pisa. His name Fibonacci. He's the guy that you can blame for all of this mess because he's the one who invented the radical symbol. So the square root symbol is also called a radical. And by the way, my favorite number, who no one has pursued this at all, is related to the Fibonacci sequence. And I'm going to give you a little teaser here. This is the Fibonacci sequence.
Is it like a boss number or something?
So what's 1 divided by 1?
1.
1. What's 2 divided by 1? 2. What's 3 divided by 2? 1 and a half. 5 divided by 3? 1.6 repeating. You could do that. It's like 1 2/3. 8 divided by 5. Now, if you continue that on out, the further you get out in that sequence, the closer you'll get to my favorite number. So,
Like how far?
How far? Well, that's a good question. How far? We might talk about that later.
How will we know when we've gotten it?
All right, so
Mr.
let's go ahead and
favorite
jump in
number.
here. So if we got the square root of 49, the square root of 49 actually has 2 answers. I don't know if you thought about that or not, but what would those 2 answers be? Yeah, exactly, 7 and negative 7. Usually when we see the square root symbol, we're going to do what's called the principal square root. And so this symbol here means the principal square root, and usually we just say 7. But just in understanding that negative 7 is also a correct answer there. If you have a negative sign on the outside, it means negative 1, literally negative 1 times 7, so that would be a negative 7. But if the negative symbol is inside the radical, try typing that into your calculator. Do square root and then negative 49. And it's going to say something like math error or yeah, something like that. Okay, and that's because, can you come up with a number times itself that gives you a negative 49? 7 doesn't work, right? Does negative 7 work? Because a negative times a negative is a positive. So there is an answer, and it's called 7i. We're not going to get into that tonight. Okay, that would be for 136 when we take that. You're going to get into this called an imaginary number. But everything we're doing right now, we're just going to say no real answer if you have something like that. And I think Math Lab, it's like a multiple choice, and there's a button that says no real answer. Nathan's saying yes. Okay, so that's that. That's pretty easy. So some basics here. If you've got 2 square roots multiplied together, just like we would expect, we can write that with a squared symbol. And so the square root of a squared, those kind of cancel each other out. You kind of think about why. Because you got 2 copies of, like say it was the square root of 2 and the square root of 2, that'd be the square root of 4. And the square root of 4 is just 2. So those are opposites of each other. And then, of course, if you've got the opposite of the square root and the opposite of the square root, it's still going to be the same thing here because a negative times a negative is a positive. And then you got some, well, they look hard, but they're really pretty easy. If you got a square root over a fraction, just think of that as 2 square roots. So what's the square root of 4 and the square root of 9?
3.
Okay, so 2/3. And that should make sense since 2/3 times 2/3, top times top, and bottom times bottom gives us 4/9. Does that make sense? So what's the square root of 3 times the square root of 3? Does that make sense? Because it'd be the square root of 9. And it follows this rule up top here. We'd really have the square root of 3 squared, which those cancel each other out, and we're just left with 3. Okay, so what would this be? Think about the rule. So we got 2 copies of that square root. What's left over?
B squared.
Just b squared minus 1. And that's it. So they cancel each other out. All right? Okay, so we're okay so far. Okay, rational versus irrational. Tell me, what's 1 times 1? 2 times 2.
4.
3 times 3. Keep it going.
20, 30, 40, 60, 80, 90, 100, 120, 130, 140, 150, 160, 170, 180, 190, 191, 192, 193, 194, 195, 196, 197, 198, 199, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122, 123, 124, 125, 126, 127, 128, 129, 130, 131, 132, 133, 134, 135, 136, 137, 138, 139, 140, 141, 142, 143, 144, 145, 146, 147, 148, 149, 150, 151, 152, 153, 154, 155, 156, 157, 158, 159, 160, 161, 162, 163, 164, 165, 166, 167, 168, 169, 170, 171, 172,
literally we can build a square which is a 1 by 1 square, right? 2 by 2, 3 by 3, like a Rubik's Cube, 3 by 3. Those are called perfect square numbers. And when you square root them, they come right out on the money. That's called rational. Okay? Rational, like a ratio, anything that can be written as a fraction, a percent, a decimal, if the decimal stops. Really, all the regular numbers that we're used to working with, those are all rational. But the ones that fall in between, so like here, the square root of 3 and the square root of 2, which are in between the square root of 1 and the square root of 4, if you type those into the calculator, you get stuff like 1.4-ish, and it's a weird decimal that goes on forever without any kind of pattern to it at all. Very similar to a very famous number. And then the square root of 3 is going to be 1.7-ish with a freaky decimal, and you can, type it in if you want to. But that's how I remember irrational. So you just think of the n as the pi symbol. Irrational like pi. Pi has two characteristics. One, the decimal, you guys do know this, don't you? Pi, the decimal goes on forever. I don't know if you knew that or not, but it does. And also doesn't have any kind of pattern to it. Okay? So that's what I think of when I think of irrational.
Then how do calculators figure it out?
They don't. They round it. So even if you use the pi button on your calculator, it's going to take a rounded value of pi and then cut it off. I think they say that if you have memorized something like 12, 13 decimals of pi, it's precise enough to do any kind of physics or calculation that we're going to need on the face of the earth. You don't need all those extra decimals. The ancient Egyptians, they just said, what the heck, let's just call it 3. It's close enough, okay? And they were able to survive. Well, yeah, they're still here. So, Babylonians and the Chinese, they called it 22/7. Type that in, and it should be a repeating decimal. So that's actually a rational number since it's a fraction, but it's very close to pi, and that's what the Chinese used. So the two characteristics of irrational is it goes on forever, and it doesn't have any kind of pattern. And that is also true for my favorite number. My favorite number is not pi. You can still name that type of thing, just like we can name pi. So my favorite number does have a name.
Irrational.
It is irrational, but there's a name for this particular number, which is irrational. What'd you say? 1.666? I heard that. All right, so let's go to higher roots. Here we go. So just like square rooting, if you've thought about this, you can cube root, you can fourth root, you can fifth root, and all you're asking yourself is, now I'm asking for a number times itself 3 times, which is going to give me 8. And that number, folks, would be 2, right? 2 times 2 times 2 is 8. And here, that number 4 times to give me 16 would also be 2. So these two expressions are equivalent to each other. They're both equal to 2. Okay? And when you get into the weird ones like this, and I would actually like you to practice, try typing that in. Yeah, so it should be second, and then you should be looking for a key that says that. So you should do like 4, and then that key, and then the 15.
You said 4.
You have to hit second. You have to hit the second key. Second.
You see this?
Yeah. So second.
Right.
That.
You get it?
Yeah, because we're for my homework, it says something 3.
Okay, so let's do a cube root. So start with your 3 for a cube root, and then second that. Second that button. And then let's do a cube root.
Oh,
It's going to give you the cube root. Did anyone not find it? Yeah, okay, so great question. If you type that in, is it going to be rational or irrational? Irrational, so it's like pi, it's a crazy number. You have to round it.
through your mouth.
There's no way around it. You have to. It depends on what they ask for. If they ask for the nearest 100th, if they ask for the nearest 10th, or something like that. You okay on the rounding though, as far as what they give you? Okay. Alright, so you guys over here, you okay with the calculator thing? Okay, John, we good? Yeah. All right. So how about the square root of negative 8?
Error.
Yep, just talked about that one, right? There's nothing times itself, which gives us negative 8. But we can do the cube root of a negative. What would that be?
2.
2 times 2 times 2 is 8.
Negative.
But negative 2 times negative 2 times negative 2 would be negative 8. Does that make sense? So this one is negative 2. So negative 2 times negative 2 times negative 2 gives us 4. And 4 times negative 2 throws it odd again. It's going to be a negative. So you can do cube roots and fifth roots, and so the odd roots of negative numbers, because that extra number in the list is
If
going
it's
to throw
4,
it.
then it'd be another.
But if it'd be an even index, right, then we're going to have problems with the negative. Yeah. John, you good on that?
Yeah.
Okay. Oops. Okay, so I want to give you a little bit of background on what radical functions look like. And give me just a second here to pull it up. So we're going to do f of x, remember that equals the same thing as y, equals the square root of x. There it is. All right, so just wave your hand at me if you can tell me one thing you notice about this graph. Okay, I heard something from Mariah here. What'd you say, Mariah?
Said it probably goes on forever.
Okay, it does. It goes on forever. Okay, make some observations. What else do you see here?
Does it hit the X?
It does not, well, it does hit the x-axis. No, it stops. So this is a little bit different from other graphs that we've seen.
Positive?
It's all positive. Okay, good. Is that to be expected? So if we have f of x equals the square root of x, for our, I don't want to give this away, but for the x values that we have, can we ever have a negative x value? If we have a negative x value, it'd be an imaginary number, remember?
Yeah, on the inside.
So if it's like a negative 9, we can't do that. So we're only graphing the real answers here, and that's why it stops. Okay. What else? I'm looking for some vocabulary for x and y that you might have just seen on your quiz
Domain
on
and
number
range.
1. Okay, so domain is the x or y? X. And you can remember that because it says domain for input. So our domain here would be what? What are all the x values that it could possibly contain for this function?
0 to
0 to infinity. So in interval notation, we would say it includes 0, because we can do the square root of 0, right? That'd be 0. And it goes up through positive infinity. That would be our domain. Sorry, I'm writing kind of sloppy. So our domain is from 0 to positive infinity. You remember the curvy thing is for the infinity? Okay, what's our range then?
Be the same.
Yeah, it'd be all the y values, and it'd be the same thing. Good. So that'd be from 0 up to positive infinity. Now there's another observation that no one's made yet, that this looks really similar to something we've seen already. Well, it's half of something that we've seen already. So what if I were to change the function and add on g of x is equal to the opposite of the square root of x. Okay, so now I'm going to take all of the numbers that were here and I'm going to make them negative. It is a parabola, isn't it? Except it's on its side. So now that's two different functions. Do you guys remember you can't have a function that has a vertical line because it's like giving you two different outputs for the same input. So it's both of them together are not a function, they're two separate functions. But it is half of a parabola, which kind of makes sense because this is the opposite of squaring. In a parabola, if I were to put one of those in here, is x squared. It's just rotated 90 degrees. Kind of cool, huh? All right.
Okay, now I'm going to do the cube root. So just to review real quick, if I were to do the cube root of 8, you would say it's 2, because you're looking for something times something times something to give you the answer. What's the cube root look like? Let's turn it on.
So, okay, is y, let me ask you this, now that you did that, is y gonna be 8 or is it gonna be 2?
Y would be 2. Yeah, and actually we can look right here. So at an input of 8, we get an output of 2. So this dot on the graph represents the cube root of 8 equals 2. So this, remember, the graph is made up of a bunch of teeny tiny dots on the graph, and every one of those dots is a separate cube root. The cube root of 0 is still 0. Does this surprise anybody? So it's a little bit different, right? Tell me what you can see here and why that might be there. So we can also do the cube root of a negative, can't we? So we talked about that earlier. And the cube root of negative 8 we said was negative 2. So it's like a reflection of itself. But I thought that was kind of cool. And then if we were to do the x cubed instead of the cube root, see how they're related to each other? So this is x cubed, something times something times something, whereas this is the cube root. And this is turned on its side. So you can have negative values for this one. What would be the domain of the cube root? What are all the input values that we could put in?
Negative infinity to infinity?
Yep, exactly. And the range?
That'd be the same too.
Same thing, exactly. All right, so what
I have
if,
a question for you. When you do that, you can put it both sides in brackets?
am I going to put both sides in brackets?
Yeah, you can put, you got parentheses.
Oh, for negative infinity to positive infinity? You'd use parentheses because you got infinity symbols. So infinity is always curvy. You can use a curvy parentheses on either
Both
side.
sides.
Yep.
Okay.
Right. Okay, so let's see what it looks like to do x minus 3 underneath the radical. So again, we'll pull this up here, and we'll do f of x equals square root of x minus. Now instead of typing in a 3, I'm going to use the letter a, and that's going to let me make a slider so we can actually vary what a is. Right now it's x minus 1. Can you see that okay? Or is that too small? Is that better? Okay, so here's the function that I'm graphing. The square root of x minus 1, and it starts here. Can anyone tell me why? Let me put it back then.
1 minus 1 is 0.
Yep, that's it. So this
So
was
we
the square root of
zero on
x.
the y-axis.
Yep, so if I plugged in a 1 for my x, okay, so I plug in a 1, 1 minus 1 is 0, and so it's actually going to kind of shift the graph over to the right because you're taking whatever your input is, and it's like taking away from that input value, so the whole thing is going to be shifted over. Does that make sense? Okay, so if I have x minus 3, then it's just going to literally be all the way out there. And of course, I can go backwards as well. So if I have x plus 3.6 is going to be over there. So that's going to shift it left and right, kind of the opposite of whatever it is. Okay, and then I'm going to do one more. So this one's going to be x plus a, and then I'm going to add on to the end of it a slider for b. Maybe. Oh, we gotta. Okay, so let's put those back at zeros before I reveal it. Okay, there it is. So there's my function. And then again, if I slide my a value, it's going to move it this way. So let's put it at x minus 3. Again, that means that if I put in a 3, I'm really starting at 0. If I put in a 4, I've now got the square root of 1, which is here. Now I'm going to, at the end of the function, add some value to whatever I get from my answer. And so tacking that onto the end is going to raise and lower my function. I don't know about you, but I just think that's awesome. Okay, you guys got any questions on that, or comments, or anything interesting that you see? Okay, later on when we do parabolas, we're going to look at exactly the same thing to take a parabola and shift it around the graph. Okay. Cube root of x plus 5, we'll just do this real quickly. Is that about what you expected? Since I said x plus 5, it's going to shift it to the left. It's still the same graph. It's just got a left shift on it. All right, we'll call it quits with that. I'm actually going to skip that stuff because this is not on your test or on your final, and so I'm not messing with it. Okay, so we're going to get to rational exponents. This is section 9.2. So the other stuff was section 9.1. So let's just take a look at this idea of 3 to the 1/2 power, okay? So 3 to the 1/2 power is going to mean the same thing as the square root of 3. You might develop a little bit of intuition here by doing 3 times 3 times 3, 3 times 3, 3, and then 1. You guys remember how we did that earlier in the semester? So right here we've got like 3 to the 1/2 power. So we're really asking, what can I multiply by twice to get me from 1 to 3? And so that's the square root of 3 multiplied by itself twice gives me a multiply by 3. So maybe that's why that works. I don't know if that makes sense to you or not. But anyway, all you have to remember is that the denominator goes in the crook. So if you got 3 to the 1/3, that denominator of the 3, it goes in the crook. And you've got 3 to the 1st, or just 3, and it's the cube root of 3. So if I had 3 to the 2/3, or written like either way, I'd put the denominator in the crook, and I'd put the exponent either here or here. And Joe and I were discussing some of the math lab stuff is going to have you do it this way, and some's going to have you do it this way. This is the preferred method as you get further and further in because it's easier. But you might have to do it either way. They both calculate out to the same thing in your calculator. So it doesn't matter if, when you go to type this into your calculator, you type in 3 and then that symbol, and then parentheses 3 squared. You can do it like that. That would be like this one. Or you can type in 3 and then the symbol, and then you can do 3, and then put that whole thing in parentheses, and then square it. They'll both come out to the same thing. Okay, so the numerator can go under the radical or above it. It's usually easier to put the numerator above around the whole thing. And the denominator goes in the crook. So I know it looks kind of funky at first, but you're going to catch on really easily. Okay, does people still need that? Go back. All right, so let's say 16 to the 3/4 power. Who can rewrite that as a radical? Anyone rewrite that as a radical? Mm-hmm. Yep. So you can write it like this, or you can write it like this. And so we would say that this is the 4th root of 16 cubed. Okay? And we would definitely be using our calculator if we wanted to evaluate that. So we would type in 16 times 16 times 16 and then do the 4th root of that. Or we can actually do this in our heads. because what is the fourth root of 16? We did that earlier. What times itself 4 times gives me 16? 2, and 2 times 2 times 2 gives me 8. So this way, like I said earlier, is actually preferred because it's usually easier to do it, especially just in your head. But they're both acceptable. 16 times 16 times 16 would be some absurdly big number, but 8, it'd be 8 times 8 times 8 times 8 actually. Since both answers are 8. Okay, so how about 8 to the 4 thirds? Who can be bold and tell me what this one is as a radical? Third root to the 4th. That's it. Yep, so the denominator goes in the crook. Other than that, pretty simple. Or you could write it as that. Both are fine. Seeing that confused look, Maggie, you alright?
So it's the final answer.
I don't know.
We're just trying to.
No, actually we can
we're
do
just
this.
writing-
Because the cube root of 8 would be 2.
Yeah.
2 times 2 times 2. And so 2 times 2 times 2 times 2 would be 16.
Okay, so
Yeah.
my answer would be 16. That's what it's like. But how's that? I don't know.
Yeah.
Yeah.
So for the next one, it would be the 4 and the crook.
But all
But what?
we're trying to do right now is to write.
Type it into the calculator. Yep. Write it as a radical, type it into the calculator. So far. So far. Okay, now this one gets a little bit more complicated. And you guys might remember, if we have 3 to the negative 2, you've done this on the quiz already, what happens with the negative exponent?
Just flipped.
Bunk bed story is not happy in the top bunk, he goes to the bottom bunk, and it's 1 over 3 to the positive 2. So we're going to do exactly the same here, the thing here. 1 over 16 to the positive 3/4 power. Yep, the 4th root of 16 cubed. Yep. The whole thing goes down to the bottom. Yep. Yep, and that again would be 2, and 2 cubed would be 8. So this would be 1/8 would be your final answer. Everyone hanging in there okay? You know, if you're given a fraction with the negative exponent, do you remember that we can just flip the fraction over and change it to a positive exponent since they're both unhappy? The 8 is unhappy 2/3 and the 27 has the unhappy 2/3, so we can just go 27 over 8 and make it positive 2/3. I don't know if you remember that rule or not, but they're both unhappy. They flip-flop. So we're going to have, in radical form, someone new, Mariah's done 3 of them here, so who wants to take it in radical form? Just do the top and then we'll do the bottom. Be bold here. You got this, Ryan. Just do, okay, so just do 27 to the 2/3 power. So the denominator goes in the correct.
Yeah, 3, and then the sign, 27, parentheses 2.
Yep. And then on the bottom, we'd have the same thing with an 8. And that's it. I think we can probably evaluate this one. What times what times what is 27? So this would be 3 squared. 3 squared would be 9. And then 2, cube root of 8, 2 squared would be 4. So 9 over 4. So somehow that right there is equal to 9 over 4. Kind of crazy.
I'm confused. So you flipped the very first fraction
Mhm.
for the negative.
Yep.
And then, oh.
The exponent applies to both of the numbers in here. So I'm going to do the cube root of 27 squared and the cube root of 8 squared.
Okay.
So I just rewrite it out here and I'm done. All right. Nathan, you hanging in there? All right. John, you good? Ryan, you feel more confident now? I made you step out in the water a little bit. All right. Okay. Okay.
Oh, that was Peter.
Peter was walking on the water.
Okay. Yeah.
That's like when you go to swim. When you're learning how to swim, you got to step off the shore. You got to go into the deeper water before you can swim. All right. So okay. So you got A through E. I don't know if can you see that okay? Okay, if you guys could just work with someone next to you, or you can try it on your own. I'd like you to try to rewrite those as a radical. So all 5 of them, rewrite as a radical, and go.
What? There's a noise in there.
E is an irrational number. E is an important irrational number. My favorite number is the log. It's less than. It is. The golden ratio. Oh, Joe, all right. Now, yeah, that's it. That's my favorite number. Yes.
What was it?
Oh, don't tell them. Let them figure it out. Joe has figured out my favorite number. Now, did you know that then I can take a credit card and I can use my credit card using that number? I can figure out where everybody's belly button is.
What?
I know it's weird. It's great. Yeah, you don't believe it? I'll do it later, not tonight. Kind of weird.
Okay.
So talk with each other. You learn better by talking. Yep.
I don't know what it means, but I think it'd be in the ring.
D's missing number.
You got it right?
I think I got it now.
I did. I sent you a video on it. Did you get my email?
I got it.
Printed this off.
I just
Oh, yeah, this is one
brush
bag.
I
Why did I do that?
didn't know if you took it back or not.
That's weird. I don't know why I did that, Joe. You're right. I did send you a video on the other one.
Yeah, I got the video for that one. I got it.
Sorry.
That one I got sent back.
All right. So Daniel, help us out here. Hey, what you got?
Yeah, I am. Not gonna lie, I'm completely lost. I watched you do all of it, and then my brain just
Okay.
Went
So the denominator goes in the correct. So this one's going to be 19. You just put the little 2 there. You
right.
don't even need the 1 because it's, not necessary. That's it. It's just a square root of 19.
That's the answer.
That's it.
All right, I got it then.
Can you try the next one? Give it a shot. The denominator goes in the crook.
So the 3
And
up
we say the
there,
cube root. Yep.
and then 5 2.
Yep. And we put the 2 on the outside of the whole thing.
Right.
You could put it right here, but this is easier. Trust me. For later on. Okay? So the denominator goes in the crook, and then the numerator goes on the outside of the whole thing. Which really should make sense, I hope, because 5 to the 2/3 power is the same thing as 5 to the 1/3 power times 5 to the 1/3 power. Because remember, when we multiply these bases, we add the exponents. So really this is like 2 copies of the cube root of 5. So when we write that out, we write the cube root of 5, and then we have 2 copies of that, which is why the numerator goes on the outside of the whole thing.
So it's 25 and 2/3?
25 and 2/3?
Yeah.
No. When you have a base of 5, or when you have a base of anything, like if it was x cubed times x to the 4th, we just add the exponents and we keep the base the same. Because the base of the exponent just counts how many of the base that we have. So this doesn't become 25. This is counting like a third of a factor of 5. And a third of a factor of 5 is 2/3 of a factor of 5. John, don't worry about it. That was extra. Okay.
Okay, got it.
Okay. Can you convert that though to radical form?
I get the 5 on the outside.
Like that?
Then I put 4K on the inside. And that was in parentheses.
The whole thing like that, or the whole
Okay.
thing
Well, that's why I did, and then I put my 3 on the outside.
like this?
Yeah, you go there, right
Or-
over the top of that right there.
Okay, yeah. So you either want to do it like this, or you're gonna put your parentheses around the whole thing.
Is that what you said that was the preferred method?
This one here. This one's easier. Okay, who can write D? This is the hard one. Who are we gonna pick on? I mean, call on. Maggie.
When you get in there.
5 in the crook.
Yep.
Square root of 5x to the third. Minus 5 in the crook, 2x to the third.
She's good. That's all you can do. Then you literally just have to figure out, if we knew what X was, we could take it and figure
Let's
out
not
the
work on
answer.
that right now.
Could you take away one from the other one right now?
No, because they're not like terms. They have to be exactly the same.
Yeah, 5 and 3s.
Yeah, but one of them has a 5x and one of them has a 2x. They're not exactly the same terms. So no, you're stuck there. All right, last one. Last one has a negative exponent. Hmm?
1 over 7 in the crook to x to the fifth.
She's on fire.
Oh my god, that's everything.
What?
Oh my god, I got it. I can't wait for that Hunger Games. Hunger Games.
I haven't read it, sorry.
It's a movie. It's never
It was a book though, wasn't it?
It's not
Alright. So now comes the fun stuff. Alright, you ready to dig in here? Yes, you are. So in review, we've already done this stuff. We had her test this on test like 1, I think, maybe test 2. But you might remember the riddle of St. Ives. Do you remember the riddle of St. Ives?
She had a bunch of wives.
Had a bunch of wives. Every wife had 7 cats. Every cat had 7 kittens. Yeah, every cat had 7 kittens. So anyway, we got 7 cubed times 7 squared, and that was 777 times 7, which would be 7 to the 5th. So that was the adding rule. Actually, we just talked about that with John. So the base stays the same. It does not become 49. You're just counting how many 7s you have multiplied together. Yes? Okay. This one we just talked about bunk beds. Here, if you've got 2 exponents in a fraction, so like 7 cubed over 7 squared, that'd be 777 over 77, and you cancel them out. So that's the subtraction rule, because they cancel each other out. This is the whole fraction rule, where you flip the fraction and make the exponent positive. We talked about that one a couple slides ago. Then you got the multiplication rule, so like 7 squared cubed would be 7, 3 times. Set 3 copies of 7, so that'd be the multiplication rule, and that's another extension of the multiplication rule, an extension of that, and yeah, so these are all actually just the same. All you really need are these 5 here. So I wanted to give you something that helped Jeremy and a couple others as I was working with them. This is my order of solving exponent rule type questions. This is my thought process that tends to works nearly every time, and it helps you avoid some traps. You always want to take care of negative exponents outside the parentheses first. So that would be like if you had 5 squared to the negative 3, you're going to take care of that first by making it 1 over 5 squared to the positive 3. You're always going to do your bunk bed stuff first. Okay. Any remaining negative exponents, if it's in a fraction, flip-flop them like bunk beds. So bunk beds first. Take care of any parentheses next, and then you cross off your pairs and simplify fractions. So it's in the video if you don't want to write it down, and yeah, you can go back and check it out. So let's put that in action here. So we've got now exponents, which are fractions. Okay. I don't want you to think of them as radicals right now, because it's easier to solve them just thinking of them as fractions. We could rewrite this as the square root of 2 times the 4th root of 2, but we get stuck pretty quickly. Okay, so any ideas? What are we going to do? Yeah, so what are we going to do with the fractions? Here's your rules over here. So you got the same base, they're both 2's. It looks like this rule here. 7 cubed times 7 squared gave me 7 to the 777 times 7, 7 gave me 5 sevens. So my rule was I added the exponents.
Would it be 1 to the 6?
So would it be 1 to the 6th? No. So how do we add fractions?
Common
Gotta have a common denominator, right? So it'd
2
be
fourths.
2 to the 1/2 plus 1/4 would be 2/4 there, which would be 2 to the 3/4. That's your answer for that one. Okay, so think back over here to this one. The exponent is counting, and it's counting how many of the base I have. I've got 3 sevens, I've got 2 sevens. So I have 5 sevens. Here I have a half of a 2, and I've got a quarter of a 2. So now I've got 3/4 of a 2. Okay. How about this one? B. Who's going to be bold and tell me what to do with that one? Back over at your rules again. It's a division, right? So what do I do with the exponents if it's a division? I subtract them. So you don't have to have these memorized if you just think about your sevens. So let's see, if I have this, I would have this. So I subtracted 3 minus 2. So I'm going to subtract these two. What is 2/3 minus 7/3? So 5 to the negative 5/3 power. And that's it. That's all you have to do. I know it takes a while to wrap your brain around the whole fraction-y thing, but you'll get there. Okay. How about this one here? What do I do when the exponents are outside of parentheses? Back to your rules. So, which one of the rules am I looking at here?
Bottom left.
This one here. So I'm going to multiply the exponents together. What is 1/2 times 4?
48.
So what?
48. 1/2 times 4.
What? Yeah, just 1/2 times 4. 1/2 times 4 over 1. 4 over 2, which is half of 4 is 2, right? So this would be x squared. So it's like half of 4. And then how about 2/3 times 4? Think of that as 4 over 1. Top times top, bottom times bottom.
3/4.
So 2/3 times 4. Top times top, bottom times bottom. 8/3. And then, okay, so do I take the y to the 4th power then?
Yes.
No, it's not in parentheses.
The 4th power is only for the numerator. So just over y. And now there's one more thing I can do.
Reduce.
Yes. So how many y's are here?
1.
1.
3. 3.
And I can rewrite that 1 is 3 over 3. Yes,
So you'd be left with 5, 3 on the top.
I would. Very good. So that's the subtraction rule. X squared y to the 5 over 3 would be your final answer. So there's just a single y there, which would be y to the ghost 1, and 1 is the same thing as 3 over 3. And I knew that I needed 3's because I had 8/3 at the top. I had to get the common denominator. Yep. All right. So how about this one here? We've got a negative exponent. So what do we do first? Flip the whole thing, right? Now, when you flip the whole thing, this is still a -2. This is still a 1/3. You don't flip any of your negatives yet. You're just flipping the entire fraction. Now what? Yes. Yes. So these two unhappy x's are going down to join the 4 that are down there. So I have x to the 6 down at the bottom. Yeah, and those 6 unhappy y's are going to have to join a third of a y up here. So we could think of that as like 6 and a third. Or why don't we rewrite that as 6? What is 6 in thirds?
6 and thirds.
Yeah, 6
2.
in
18 over
thirds.
3?
Oh,
Yeah, 18 thirds would be 6. So we'd have 19 thirds, or 6 and a third is the same thing as 19 thirds of a y up top. Okay, and then that whole thing is to the 2/3 power. So what do I do next? I'm going to rewrite here. So what do we do with the exponent on the outside of a parentheses? It's actually, these are the same rule. It's the multiplication rule. So you can go back to your 7s again. This is 3 copies of 7 squared. It'll be 7 to the 6th. So what is 19 thirds times 2/3? Top times top, bottom times bottom. 19 times 2?
38.
38 over 9. And then 6 over 1, top times top, 12 over 3, which I suppose reduces to just a 4. And that's it. Y to the 38 ninths over x to the 4th. Here's what I hope you realize. I hope you realize that we've already done this. Everything up here we've already done. You just don't have regular exponents, you've got fraction exponents. So here's my recommendation. You start freaking out on the quiz, you're not sure what to do. Rewrite the problem without the fractions. Okay? In other words, give yourself a new problem that says x to the 4th, y to the negative 6 over x to the negative 2, y to the, just make something up, 3. Okay? To the negative 2 power. Work it out and watch what you do. Watch when you multiply. Watch when you add. Watch when you subtract. And then go back and just apply it to the fractions. There's nothing new that we were learning here. It's just applying it to fractions from what we had before. Now, if you feel shaky on the rules, I would definitely go back and just work with some basic stuff like this to get the rules in your head. And MyMathLab is not going to do that for you. So mathtv.com, Khan Academy, you go back to your old quizzes, get these rules in your head so that you can use them with fractions, but it's going to be something you're going to have to work on for yourself so you really feel comfortable with them. Okay? So do one more. Okay. What do we do here? Any ideas?
Factor out.
Factor, is that what you meant? You did this kind of thing.
Yeah. Right.
So what is this kind of thing?
So m to the 3/4 times m to 5/4.
Yeah, okay, so that's not factoring, that's called the
Foil.
distributive property. Yeah, exactly, distributive property.
I'm getting there.
Yeah, definitely. Okay, so let's say we flip out, we forget what to do with the exponents, so we're going to go to an easier question. M times m to the 5th minus m to the 4th. Okay, what would be that? That would be m to the 6th, and that would be minus m to the 5th, so we added, right? So do you see how it'd be really tempting to multiply those fractions? Because if you just have numbers, that's exactly what you do. You multiply the numbers. But since they're exponents, you're going to add the exponents. So what is 3/4 plus 5/4? Oh, you see, yeah, 8 over 4. And 8 over 4 is just 2. Minus, what's 3/4 plus 1/4? 4 over 4, which is just 1. So that nasty right there is just m squared minus m. if you can picture in your head, like if you have m squared, picture in your head 2m side by side. And then if you just have m, picture in your head 1m. And then just picture like 3/4 of an m, which is kind of weird at first. That's going to help you begin to think about, so this would be an m plus a little bit more of an m, which is, might help. All right, so the only other thing is you have to be able to also go back to the exponents. So if you're given the radical form, this would be m to the 3/5, yes. And this would be m to the, so the denominator goes in the crook, and the crook here isn't written. If it's not written, it's assumed to be a,
1,
no,
2.
it's a square root, so it's assumed to be a 2. We are going to real quick here do a review game for the test tomorrow. You're good? Okay. Or not tomorrow. Next week. Yeah. Okay, and then you finish it up. What would we do the exponents? Add, subtract, or multiply? You realize that we're never dividing the exponents. I don't know if you realize that or not. It's just 3 choices. So yeah, we're going to add. That's like the 7 squared times 7 cubed is 7 to the 5th. Let's see here. We don't have common denominators. Times by 2, times by 2, times by 5, times by 5, and I get m to the 11/10. Okay, how about this one? P to the, crit goes in the denominator, 5/3. P to the, crit goes in the denominator, 3/2, so the 2 is a ghosty here that we don't normally write. Okay, what do I do to the exponents? What do I do to the exponents? I subtract. Johnny giving me that look. You okay?
Yeah.
All right.
Thinking.
Okay. So I got to get my common denominator, which would be 6 times by 2 times by 2 times by 3 times by 3. 10 minus 9. So p to the 1/6. And then, ooh, wow, look at that thing. Woo-hoo. Any ideas? Just focus on the middle, the inside. That'd be x to the, yep. And then let's put parentheses around that because the whole thing, yes, to the 4th, yes. So what would we do for that rule?
That would be times.
That'd be the times rule, yes. And top times top, bottom times bottom gives me 1/12. And I'm done.
Wait, on B, did you subtract because that's the rule?
Yes, I subtracted because when I have p's that are stacked on each other, so I've got like,
Oh, we cancel.
yes, exactly. So like here 2 p's would cancel out, so I subtract and get 3 p's.
Yeah.
That's the subtraction rule. Good. Always go back to the easier stuff. All right, so we're going to do a review game for our test next week. First of all, next week you have nothing about radicals for your test. That's for test 4. So don't worry about learning this stuff for next week. It is cumulative, however, from what I can see, there's only a couple questions from test 1 and 2. It's mostly all factoring. Really make sure that you're good with factoring, okay? Your concept map, I can't let you use it on the quiz, but if you memorize it, then you can use it in your brain. So I would, and the thing on your quiz that I noticed from last week, the cubes, the sums and differences of cubes. There's probably 5 of us in here that I had to go back over that with. So we need to study that, okay? Story problems, the only story problems that you're going to see are the ones like we did today. You're not going to have the ones from way back when they were linear systems of equations. So don't, like the mixtures and stuff like that, you're not going to have that stuff. And then it's only 20 problems because there's so much factoring. It's just like every question can be like 3 or 4 factoring type things if it's like a multiply or something like that. So you guys have any questions about just in general the test or anything that came up? It's like, man, I really wish that we could go over this. Knowing that I am making videos for a couple things with story problems and stuff. Okay, well I got a Kahoot game for us to finish up. And the winner, again, will get a bonus point on their test, which is 4%. So get out your devices if you have a device to use, a smartphone or whatnot. Are we going to do partners or are we going to do individuals?
Let's do individuals actually.
How many of you do not have a device that you can use?
What are we looking for a device?
Smartphone, tablet, computer. Let's just to be fair, let's have everyone partner up. 2, 4, 6, 8, 10. So everyone can have a partner. You can partner up as you want.
Kahoot, yeah.
Yeah, Mika. Oh, you can take off, Mika. I don't know. Okay.
Okay.
If you get onto the video, then the Kahoot will be on there, and you can review from that. All right.
Kahoot.com.
Yeah, go to Kahoot.it. Kahoot.it.
Kahoot.it.
Yep. All right, game pin is 23002. 23002. So who is our person out then? Since Mika's leaving, do you want to join the guys over here? We'll have just a group of 3. Because if you guys win, I'm going to be giving out 3 bonus points. It's a pretty good deal in here. So you got your sheet of paper, pencil, you got your calculators ready to go. See you later. Yourself a hot beverage before we get going here. You've never tried it?
I think I have, but it's a long time ago.
Oh, it's good.
It feels really
We'll go.
Okay, we got the Marissa squad, we got the John team.
Hey, what is that? I thought it just said
Chance and Maggie, very creative guys. All right.
I was trying to get
job.
Okay.
be creative.
Is it working there, Nathan? You able to get in?
Yeah, whenever he'll start and it'll.
All right. We got the math minions. Nicely done. Here we go. 13 questions, okay? You got 2 minutes max on each one of these. I'll try to make them shorter, though. Okay, what's the slope of the line going through the points -6, 0 and 8, 7? The quicker you answer, the more Kahoot points you get.
Which way?
Gotta have our music. Everybody's answered. All but one group said a half, one group said -half. It should be +half. Right?
All right.
Right? Is that right? Oh, yeah, because so it'd be 7 minus 0, and 8 minus -6 would be 7 over 14. So, yeah. Good. You can't.
Oh, you're on my man.
All right. So who's in the lead? John team is in the lead.
Dr.
They're
Keller,
all very close. All right.
Colleague.
Okay, now write the full equation, same ordered pairs, so you already have your slope. You're writing the full equation in slope-intercept form. Someone already has an answer. Keep working out anyway, just to practice.
Okay.
0 equals half of negative 6 plus b. 0 equals negative 3 plus b. Plus 3 plus 3. 3 equals b. Do you feel like we need to practice on that, or are you guys okay for the
Okay,
test?
wait, I'm gonna write it down. Like,
We need more practice.
0 equals 1 half.
I do anyways. I know I need practice. Go.
Yeah, so y equals m, and then your x is negative 6. Ouch. So there, we can see better. So add 3, 3 equals b. So once you get your b value, you rewrite the full equation as a half x plus 3. Y equals mx plus b. We want to do a practice? No, okay. All right, John team. Got lucky here. So,
Bad.
so Chance and Maggie, I didn't put me and Trevor happy. All right. What is the least common denominator for these denominators? So this is pretending that we've got 3 fractions with this is a factor, this is a factor. As if we had this. Just looking for the common.
Can we just get our points and go?
You guys were in first place. What? How many points did you have? It was 18. I'll add that back onto your score again. It's like 1800 something. I don't remember exactly. Okay. I should have factored this over here. If we still, you better mark something. You got 10 seconds. Who are we waiting on? Oh, we're waiting on them now. So, how many you got that? 2? Ooh.
Are they?
What?
Is the red
I
part and the
couldn't
triangle, is that the same thing as
This right here.
that one?
This is what I
This one has an x plus 3, and this one has an x
Oh,
minus
that's
3.
what it is.
is the
Okay. I've
difference.
got it. I just.
So, who is this then?
I slept.
Oh, you clicked the wrong
Yeah,
one.
because I
That's
was
right.
trying to go for blue, but
Okay.
track
So
back.
can I
Track
kick
back.
out the John team? Okay, so 1848. I'm gonna add to your guys' score at the end. And did you guys just not get that one right, or
Yeah.
okay? So I'm gonna kick that
We were
out.
robbed.
Why is there 2 of them then?
Why'd you kick us
I-
out?
Why'd you kick
We
us
were
out?
entered.
Oh, there we are. You can go ahead.
Why is there two?
I made one and then they made one.
Another one?
Yeah, I thought
Yeah,
you were
we
using
got
my
one.
laptop.
Well, I would use the laptop if I were you, because if your phone turns off, it'll kick you out. So is that capital John or lowercase John?
Mine's lowercase.
So I think now we are ready, right?
Alright.
Okay, so the Math Minions have pulled into the lead even after accounting for your 1848. So second place, who's the Math Minions? So first place, second place, John team.
Right over there. You already.
Oh, but we're ignoring them. And then third place, and then are you guys not on the board?
Where Marissa?
Oh, the Mercer. Oh, you guys are third place. Yeah, and then you guys aren't on the board yet. That's right, because you hit the wrong one that time.
Yep.
All right, here we go. Write an expression for the product of two consecutive integers. This is something that you might see next week. Everyone's answered, and we got a split between red and blue. This would be the product of two consecutive even or two consecutive odd. Is it because it skips one? This would be consecutive because it's one after another. At least we both did products. That's good. All right, where's our scorer standings here? Math Minions. John team gets the whole time. You guys see why? Consecutive one after another.
Yeah.
This one. All right, Chance and Maggie are on the board. All right, here we go. Write expression for 3 more than 5 times the sum of 2 consecutive numbers. I'm trying to. So, you know what's consecutive? X. That's the next question. Alright. So, ouch. What happened? Oh, you guys all selected the product of 2 consecutive integers. So the sum of 2 consecutive integers times by 5 and added 3.
That was
Rats. Alright, now that pulls the, where are you guys at here? Oh, you are the Math Minions. Oh, you guys are on fire. Alright. John's. You got one last time, though, didn't you? I thought you did. Since you signed in again, you haven't got one. Alright. Okay, factor completely. If unfactorable, select prime. You're all correct. All right, very good. Finally. Mathemanian's still in the lead. Marissa's squad second place. All right, everyone's on the board now. Here we go. What does soap mean? Nicely done. All right, and the standings look like they're about the same. All right. Solve this equation by factoring. Actually solving this time, not just factoring. Final answers. I should have put equals 0. It is the blue one, yes. That's correct. All right, very good, guys. Whoa.
Good thinking.
Okay.
What the heck?
Okay. It's a free for all. Select one. Oh, I know what it was. It was C6. Just select one. What?
Wait, send it again.
Oh, all of you selected the blue one?
Yeah.
So
Okay.
No chance of that happening. So this one should have been C96 minus 81.
You obviously did it wrong.
Yeah, so what is that?
It's high school.
Perfect squares college. So we do C cubed minus 9, C cubed plus 9. So we square rooted both of those. And then I was trying to trick you because I wanted to see if some of you would take that a step further. But because that's a C cubed, you can't. Right? So that then would be your final answer. Right? So not going to hurt anybody. Solve the equation. Finally, yes, y'all got it. 0 and 3 is correct. Ooh, it's anybody's ball game here. John team is not nearly as far behind as it looks because they got 1,800 points to their benefit. Got 3 more questions. Okay, so you're going to have something like this. Ask me for these Yes. that. Everyone picked a different one. And who got it?
Hey,
Chance and Maggie.
don't leave me hanging.
Hey, we do need to look at this then. So this would be a negative 6x plus 15y equals 57. And then when you stack them up,
Oh, is that what we're supposed to?
yeah. So
24y equals 72.
24y equals, what was it? 72. Divide by 24, divide by 24, y equals 3. Okay, so that narrows it down to, well, yeah, that's actually the answer right there. So to get your final answer, though, you plug the 3 back into one of the equations and or for the y.
I turned it back here now.
Figure out what your x is. No factoring needed here. Remember, if you got 2 variables, you have to solve it using elimination, substitution, or graphing, because these are lines. It's where the 2 lines cross. All right.
Did we go over that one?
I just did.
Okay.
What did you miss, John?
I missed the whole.
You missed the whole explanation?
I
I'll show you after.
okay.
I'll go back over it with you. Okay, factor completely. If unfactorable, indicate that the polynomial is prime. So this is the language that they use in the test. I just want to use the same language. This means factor out the GCF. Very simple. Everyone got it. All right. Nicely done. So look at that language there. All they're asking for is the GCF. Okay. That's the language you're going to see next week. Comes down to this. Factor completely. Oh, I completely forgot about factoring out a 3. Oh, it is yellow. I would have missed that. Wow.
So we won.
So you can't factor out a 3. Rats. Yeah, the two of you who picked prime, I would have picked prime too. Because it looks, yeah, it's not a difference of squares.
I tried
It's
talking.
Third.
Who put red?
It was the last second.
First of all, there's
Oh.
only 14, so we can't be in
Exactly.
7.
All right, now, hey, so we got 18, what was it, 18, 40,
Yeah, we didn't win.
1848 added to that score. So that would
We should
be,
get a couple hundred extra.
so that'd be 6,100. Okay, so first place is our math minions. Very good job, math minions. Bonus point for you
I know
guys.
what I wanna say.
Coming up with bad stuff.
All right, guys, thank you. Great job tonight. Please continue asking me questions. Study. Don't study on Tuesday. Study on
Sunday.
the whole week.
Monday.
Oh, yeah.
Study the whole week for this thing.
You bet I will.
Please. Grab yourself some apple cider before you leave. Have a good night.